Welcome back, ladies and gentlemen. It is I, Coach Goo, back with another fun-filled, action-packed, non-flipped Algebra 2 classroom video. We're not messing up today. We've pressed the record button. Let me make sure. Yes. And today, we're going to be learning all about inverse functions. So let's get that word in our mind. Inverse functions. We're going to be dealing with the inverse. So look down to here on the second page. The idea of an inverse is often to undo or counterbalance something else. When we solve equations, we use inverse operations. You can think about it like the opposite. What's the inverse operation of addition? That'd be subtraction. So I'm not going to write this all the way. What's the inverse operation of subtraction? That's going to be addition. What's the inverse operation of multiplication? That's going to be division. What's the inverse application of division? Multiplication. And then finally, what's the inverse, the opposite of square root equations? If the square root, we would take the square. So we'd like use the little exponent. Bam, like that. All right, so but be careful though. When you're finding inverses, it's not just opposites. Look at this. What is an inverse? You've seen the word inverse used in various ways. This looks like a copy and paste. The additive inverse of 3 is -3. The multiplicative inverse of 5 is 1 over 5. Anyways, let's find the inverse of a relation. Ooh, you can find the inverse of relations. Check this out. A. What is the inverse of relation A? Check this out. I already said that. Relation S. Let's say X, the domain is 0, 2, 3, and 4. And the range Y is -1, 0, 2, and 3. Then the inverse, boom, of relation S would be like this. The domain X would be -1, 0, 2, and 3. And the range Y would be 0, 2, 3, and 4. Oh my goodness, wait a second. Let's take a second now and hypothesize how was the inverse of S found. So guys, take a second and I want you to write something in this blank. How do you think they found the inverse? So guys, the way that the inverse was found is they switched the X's and Y's, or the range and the domain just switched places. I wonder if any of you guys saw that one. So let's move down into some examples then. Finding and graphing inverses. So I'm going to make sure to show this whole page at once. Okay, so finding and graphing inverses. Identify the domain and the range of the relation and its inverse. Graph the relation and its inverse. You know, we're going to have to zoom in on this one. Boom, here we go. So the domain and the range. So the original domain of this relation right here is going to be, remember, bracket 1, 3, 4, 5, and 6. And the range of the original relation is going to be 0, 1, 2, 3, and 5. Those are just the X and Y values that we see up here. All right, so let's graph these points using the domain and range. So we've got 1, 0, which is right here. Then we've got 3, 1, which is right here. 4, 2, which is right here. 5, 3, which is right here. And 6, 5, 6, 5, right there, okay? So now let's find the inverse. I'm going to use red. So remember, for the inverse, we're just switching the domain and range. So now, for the inverse, the X is going to be it's going to be 0, 1, 2, 3, and 5. And the Y's are going to be what the domain used to be, 1, 3, 4, 5, and 6. So let's graph this. This time we've got 0, 1, 0, 1 right here. We've got 1, 3, which is right here. We've got 4, 2, right? Or we got 2, 4, sorry. 2, 4, which is right here. We've got 3, 5. And we have 5, 6 right here. 5 is right here. 1, 2, 3, 4, 5, 6. There we go. So let's write the domain and range now of the inverse. So the domain of this inverse relation is going to be 0, 1, 2, 3, and 5. And the range is going to be 1, 3, 4, 5, and 6. There we go. And so now let's describe, is this relation a function? Is the original relation a function? Yes, it is. And is the inverse a function? Yes, it is. That is because we do not see any repeating x values that go to different y values. And these pass the vertical line test. And this inverse is a reflection over, you can see that this inverse reflects exactly over the line y equals x. You see, that's y equals x right there, and this is a perfect mirror image or reflection over that line. So now guys, I want you to try this next set down here, finding and graphing inverses. Find the domain and range of the original relationship, put the x and y's, graph it, then do the same thing for the inverses. Now guys, we're moving on to algebraic inverses. Oh my goodness, algebraic inverses. So, for example, they give us the function f of x equals 2x plus 1, and we need to write the inverse of this function. So first, let's see what the inverse of the function would be. Remember, when we wanted to find the inverse of that relation, we switched the x's and y's. So in this sense, we're going to do the exact same thing. So look at this. Original, we're going to write this in terms of y. So instead of f of x, I'm going to write y. Okay, so I'm going to write y equals 2x plus 1. Because remember, f of x is the same thing as y essentially. So now we're going to switch the y and the x. So it's going to become x equals 2y plus 1 because we're looking for the inverse. Okay? And so now I'm just going to solve for y to find my equation. So here we go. We're going to subtract 1 from both sides. Boom, boom. X minus 1 equals 2y. Then we're going to divide by 2 on both sides to get my y alone. Divide by 2, divide by 2. And my final answer is going to be y equals x minus 1 over 2. Or I can rewrite this as x over 2 minus 1 over 2. There we go. So this is in terms of y, but remember, we want to use that f of x, and we want to show that it's the inverse function. So here's a new one for you. Maybe you've seen this before. Instead of writing f of x, because f of x is our original function, we need to show that it's the inverse function, so we're going to go with this. F, little negative 1 up here, x. This means f inverse. Well, it means inverse of f of x. Equals, and then our equation was x over 2 minus 1 over 2. All right, so let's go ahead and graph these two functions. We had the original, which was 2x plus 1. So the y-intercept is positive 1 right here. And then we're going to go up 2 over 1, up 2 over 1, up 2 over 1. Boom. There's one of that's my original function. Hey. And it's a line, so we're going to put some arrows. And then our inverse function, let's see what that looks like. It's going to be x, the y-intercept is negative 1/2, so negative 1/2 is like about right here. And my slope is 1 over 2, so it's going to be up 1 over 2, up 1 over 2, up 1 over 2, right here, like this. And let's combine those points to make, oh yeah, to make my inverse function line. Boom! And you can see that there's a mirror image here somewhere, all right? All right, I want you guys to try problem number 2 right here. And let's do this last one together, okay? Because there's an interesting operation here. So write the inverse of h of x equals x cubed plus 8. So we're going to write it, the original, which would be y equals x cubed plus 8. Now let's write inverse functions. So we're going to change the x and the y spot. So x equals y cubed plus 8. And now let's solve for this. So we're going to subtract by 8 on both sides. So now we have x minus 8 equals y cubed. And to get rid of the cubes, we need to take the cube root. That's the square root symbol with a little 3 right here. Boom. Boom. And so my answer would end up being y equals the cube root of x minus 8. And that is the answer right there. Except we're not going to write y. We're going to switch out the y for the f negative 1 x, the inverse of f of of h. Hello. H inverse of x. There we go. And that would be my complete, perfect final answer. So guys, now we have found inverses both geometrically by graphing, those are the first examples we did, and algebraically, those are those examples we just did. And the key step always when we found the inverse is to switch the x and the y's, the x's and the y's, and that was the key. And this, guys, is going to conclude today's notes. So I will see you in the next one. Peace!